Hello folks, congrats on finishing chapter 13. We're going to jump back to chapter 9. This is Mr. Gallagher here. Let's get started with chapter 9. Going to get started with 9.1 sequences. I want you to start thinking about what the next number in these sequences could be. So go ahead and pause, take a quick second, look at each of these, and we'll get going. So for this one, what are we doing? Well, each time we go, what are we doing? We're subtracting 3. So subtract 3 again. This number is going to become 13. What about for this one? 3, 6, 12. How do we get to that? Well, we multiply by 2. Multiply by 2. That's going to work. So 24 times 2 will give us 48. Now this one was hard. I don't expect any of you necessarily got it, so let's look through. 1, 1, 2, 3, 5. Add nothing, multiply by 1. What do we do? Well, 2 is 1 plus 1. 3 is 2 plus 1. 5 is 2 plus 3. 8 is 5 plus 3. So this is going to be 8 plus 5, or 13. All right, so we dealt with sequences previously, or you all have in geometry. We're going to delve in a little bit into how mathematicians really deal with them. Mathematicians are lazy, meaning we like to write these out in the most basic way possible, and that also means generally having its own notation. So let's go through some of the definitions we need for this. We're going to start out with the definition of a sequence. All a sequence is an ordered list of numbers. So all it matters is that the numbers do have a set of orders to them. And we call these based off of their term, or which number it is. The first term we're going to call A1. The second term we call A sub 2, right? This is a subset here. The third is A sub 3. And we get out into some funky ones here. Let's say you're looking for a general term, right? Instead of using x, we use n. So we'll have A sub n. And then the term before that is going to be A sub n minus 1, right? This is some unknown term. This is the term 1 before it, right? N has gone down by 1, and we'll have 1 larger than that. Now, like I said, we want to figure out the way that mathematicians deal with these, and instead of just writing them out like this, we try to figure out how we can write these as a whole. We have two different ways that we use to write sequences. The first of those is called a recursive formula. And the other is an explicit formula. Explicit. So what's the difference between these? Well, a recursive formula, recursion or recursive, means we're going to repeat something over and over again. So a recursive formula tells you what the next term is going to be. So it tells the next term, and it tells you that based off the previous term. So let's say we were looking at a sequence here. Let's say it was 2, 5, 8, 11. What's happening? We're adding 3 each time. So we're going to say that the nth term will be equal to the term 1 before it, and then what are we doing to get to the next one? We're adding 3. The other important part, this tells us important information about where we're going, but we need to know where we started. We need to figure out what the first term was, otherwise we could be adding 3 to anything to figure this out. So we need our first term, or a sub 1, and what is that in this case? It's 2. Right. So that's a recursive formula, right? It tells us it based off of the previous term. But what if you just had the starting term and you wanted to look at the 3000th term, right? You don't want to have to do this 3000 times. This is where an explicit formula comes into use. An explicit formula tells you the value of a term directly. You don't need any of the other terms to know this. So the explicit formula tells the value of a term directly. And so the way we're going to deal with this, let's say we had 4, 5, 6, 7. We're going to say, okay, this is the first term, the second term, and the third term. And it goes 4, 5, 6, right? So what we're doing to get to each term is pretty obvious, but we need to figure out how exactly we're doing it. So we're adding 1 to each of these, right? Plus 1, plus 1. So we know that the term is going to have to do something with n, right? We're looking, we go from 1 to 4. Each time we're going up by 1, we're just going up by 1. But if we look at that, then this is going to give us 1. So we're going to need something extra to get to 4. How much more do we need? Well, we need 3. Let's make sure that works for everything. 1 plus 3, good. 2 plus 3, good. 3 plus 3, we're all set. So this is nice because we don't need any of the other terms. If we're looking for the 3,000th term, we just put 3,000 in here, and that gives us our value for that. We don't have to go, well, okay, what's the 5th, 6th, 7th, and so on term. Let's look at a couple more examples of these. Let's look at another example of a recursive to start. Let's say you had 70, then you had 66, 62, and 58. So what's happening each time? Each time we're subtracting 4, meaning that our term is going to be whatever the original term was or the previous term was, then we're going to subtract 4. Then we're also going to need the starting term or the starting value, which was 70. Let's look at another explicit because these tend to be harder. Let's say you have 3, 8, 13, 15, and so on. Now this one's a little more confusing. What's happening? Well, we're going up by 5 each time. Hold on, this number is not correct. Let's make that 18. So we have our terms, right? This is our n, our first, second, and third term. First term is 3, 8, and 13. Each time we go up by 1 in n, we're going up by 5. So we know that a sub n will have to be going up by 5, and then we have to figure out what we need to do. So if we do that for 1, we get 5, but 5 is not 3. How do we need to make these the same? We have to subtract 2. So we take whatever the n number is, whatever the nth term is, and we multiply it by 5, subtract 2. Let's make sure this works. So we get 5 minus 2, great. 10 minus 2, 8. And 15 minus 2 gives us 13. So this is our formula for this. And let's go over recursive, one more that's slightly more difficult to see if we can actually figure out how to do this. Let's say you have 1, 2, 4, 7, 11, 16. Well, what's happening here? Well, add 1, add 2, add 3. Oh, look, that's what's happening. So we're just adding over and over, no multiplication. So this time we're adding 1. This time we're adding 2, adding 3. And let's mark these terms to see if we can figure out what this is going to look like. It's the first term. This is the second term. This is the third term. So what are we doing? Well, we're adding 1 to get to the second term. We're adding 2 to get to the third. We're adding 3 to get to the fourth term. We are taking 1 less than the term and adding it to whatever the previous number was. Little confusing to see, but that's what's happening here. We're adding 1 less, right? 2 minus 1, 3 minus 1, 4 minus 1. So the way we're going to write this as a recursive formula is our new term will be equal to whatever the last term is, plus, what are we adding? Well, we're adding whatever the term value is, but then we're subtracting 1, right? To get to the fourth term, we're adding 3, or 4 minus 1. And where did we start? We started at 1. So that would be our recursive formula for that. Let's go through an example of a set of images or a set of blocks. See what this looks like. So let's say we have some blocks. We start off with 1, then we add another layer underneath. Then to that one, we're going to add another layer. And another layer. And we'll keep doing that. That keeps going on. So if we're doing that, let's say we want to look at how many blocks we'll have in the 100th term. Means we're not going to want a recursive formula because we don't want to do this 100 times. So let's see if we can figure out what's happening. Well, how many blocks do we have in here? We start with 1. How many do we add to get to this? We add 2, then we add 3, right? 3 blocks here, and we keep doing that all the way up until we get to 100. And there was actually a very smart guy who actually figured this out. He goes by Johann Carl Friedrich Gauss. We talked about him a little bit earlier, but he actually was really smart. He was, like some smart students, he got very bored, and so when his headmaster told him to punish him, he said, add up all the numbers between 1 and 100. He came up with this. The headmaster thought it would take him forever, but Gauss figured out this really quick way to do it. He said, well, if we have this, what if I flip it? So he flips it, he starts with 100, and then he says, this is the same as if we start with 100 and keep subtracting all our way down to 1. What happens if I add those? Well, this is going to become 101 plus 101 plus 101 all the way over to here. So this is 101. And how many times do we have that? Well, we have that 1 through 100. So we have that 100 times. But he said this is the same thing repeated twice, right? It's what we need repeated twice. So we're going to divide it by 2. And he found out that the correct number was 5,080. Headmaster came back in a couple of minutes. Headmaster saw that, and apparently he had to spend a couple of hours just checking to confirm whether Gauss had gotten it right. So this is the correct answer for 580, but we might be able to expand that. Let's look at that if we were looking at what the nth term is, right? Or some unknown term. Well, where would we start? We'd start at 1. We'd go up to 2 and 3, so on, all the way up to n. Right. We're doing this for the explicit formula here. The explicit is the harder one to find here. So we do that all the way up to n, and then we flip that. So we start with n, we have n minus 1, we have n minus 2, and so on, all the way down to 1. What does this leave us with if we add each of these terms? Well, we get n plus 1 plus n plus 1, and so on, all the way down to here where we get n plus 1. How many of these do we have? Well, we have n different terms. So this is n times n plus 1. Once again, we have to divide this by 2. So the explicit formula for this is n times n plus 1 over 2 is equal to a to the n. It's a handy one to have if you want to use it as a cool trick, show people how quick you can add up all the numbers together. What about the recursive? Well, for the recursive, what are we doing? We have one term, it starts 1, then we added 2, then we added 3, and so on. So this would be 1, 3, 7, and so on. What are we looking at? Well, our terms, what do they do to get to the initial one? So the first term, to get to the next one, adds 2. To get to the second, what are we doing? We are adding whatever the number is, whatever the term number is, to get to this. So our new term is going to be equal to the old term, right? This is an a times n minus 1. This is the n minus 1th term. Then we're going to add n to get to it. So these are sequences. You discussed them previously, and now we have some ways of actually looking at them at larger numbers or trying to figure out general forms. Let's get to some practice problems for you. So again, it's always important that you guys do these, pause, make sure that you get them done, and then come back to check these. So for the first one, let's give you a sequence. Let's say you have 7, 11, 15, and 19. I want you to give me the recursive and the explicit formula for that. And then find the recursive formula for 1, 2, 6, 24, 120. So go ahead and do these. Make sure you're doing them on your own, and then come back to me when you're done. All right, let's get started here. What's happening with this? Every time we're going up, we're adding 4. Makes the recursive formula easy. What's our next term? Well, it's going to be the previous term, and then we're going to add 4. And where did we start? We started at 7. For the explicit, we're going to have to do that thing where we check the terms. We have 1, 2, and 3, and then we have 7, 11, and 15. So what are we doing? Once again, we're adding 4, so we know that we're going to have a to the n is equal to 4n, and then what are we doing? Well, 4n, right? How do we get 7? We have to add 3. So our explicit form is that, and our recursive form looks like that. Let's look at our recursive for this. So what's happening here? Well, we have 1, 2, 6, 24, 120. This one's not quite as simple, so let's see what's happening. We add 1, we add 4, we add a ton, so this isn't going to be adding. What about multiplication? So we multiply by 2, that would work. Multiply by 3, multiply by 4, multiply by 5. Looks like what's happening is we're multiplying by the next number. So we get times 2, times 3, times 4, and times 5. Right? So to get to the second term, we multiply by 2. So what does this mean? It means that our new term is going to be the old term, and we're going to multiply it by whatever the term number is. And that will be our recursive formula. Where did we start? We started at 1. So that is section 9.1. Go ahead and get started on the homework and then move on to 9.2.